Hello. Please solve the following equation to enter the safe house. Thank you.
What in the world, are we supposed to solve something now?
For letting you answer, I'm going to show you how to do these equations. That you must know before starting this is that A equals the amount predicted, P is the principal amount, R is the rate in decimal, N equals the number of compoundings in a year, and T equals to the time in years. First off, we have years and amount. At 0 years, you have P amount. At 1, you have P plus PR equals to P parentheses 1 plus R parentheses. At 2, you have P parentheses 1 plus R parentheses plus P parentheses 1 plus R parentheses R equals to P parentheses 1 plus R parentheses 1 plus R parentheses, which equals and can be also simplified even further to P parentheses 1 plus R parentheses squared. At 3, you have P parentheses 1 plus R parentheses squared plus P parentheses 1 plus R parentheses squared, which equals to P parentheses 1 plus R parentheses cubed. The basic equation for this is pretty much that at T years, the amount is P to the subscriptor of T, which equals to P parentheses 1 plus R parentheses to the power of T. Next on, if you compound it 9 times per year, the annual rate R has to be divided by N, and the operation parentheses 1 plus R over N parentheses will be done N times per year. The equation for this is bracket parentheses 1 plus R over N parentheses to the power of T bracket to the power of N, which equals to parentheses 1 plus R over N parentheses to the power of N times T, which pretty much equals to A equals P parentheses 1 plus R over N parentheses to the power of N times T. To find continuous compounding is when N increases without bound. In the formula for N compoundings per year, let N equal N over R. First off, A equals P parentheses 1 plus R over N parentheses to the power of NT, which is the amount of N compounding. Next, we have P parentheses 1 R over MR parentheses to the power of MRT, which you actually substitute MR for N. Next, we have P parentheses 1 plus R over M parentheses to the power of MR squared, which is simplifying it. Lastly, you have P bracket parentheses 1 plus 1 over M parentheses to the power of M bracket to the power of N times T, which is the property of exponents. Lastly, we have E, which equals to 1 plus 1 over R parentheses to the power of N. As M gets bigger, from this we conclude that A equals PE to the power of RT, which actually E is about 2.718. Now that I have finished explaining to you how to solve for these equations, you will have to solve your own equation in order to get into the safe house. The first part is that Ashley deposits $3,000 into an account that pays 2% interest compounded monthly. How much money will there be in the account after 6 years if it is compounded? The equation that you will use for this is A equals P parentheses 1 plus R over N parentheses to the power of N times T. The information that you get is that A is the number that you're looking for, P, which is the principal amount, is $3,000, R, which is the rate in decimal, is actually 2% interest first, but then you switch it over to a decimal, which will give you 0.02. N, the number of compounds in a year, which is actually being compounded monthly, which equals to 12 months in a year, which is 12. T, the time in years, is 6 years, which is being compounded by. After you have all this information, you will just have to plug it into your equation. That should give you A equals $3,000, parentheses 1 plus 0.02 over 12, parentheses to the power of 12 times 6, Next off, you will have to multiply the powers, which is 6 times 12, which should equal to 72. That 72, you will have to plug it into your new equation you will have to write next, which is A equals $3,000, parentheses 1 plus 0.02 over 12, parentheses 72. After that, you will just have to plug in all of that equation into your calculator to get your final answer, which should give you A equals $3,382.15. Part 2. If Ashley's money gets compounded continuously, then how much money will there be? For this, you will be using the equation for continuous compounding, which is A equals PE to the power of RT. The information that you get for this is A is the number that you're looking for, E is about 2.718, which there is actually a button in your calculator that you will just have to type in instead of actually putting 2.718. R, which is the rate in decimal, which actually first is 2%, which you will convert over to a decimal and will give you 0.02. P is the principal amount, which is $3,000. T, the time in years, is 6. After you have all this information, you will just have to plug it into the equation, which will be A equals $3,000 E to the power of 0.02 times 6. After you have this, you will just have to plug it all in into your calculator, which will give you your final answer, which will be A equals $3,382.49.
Look, Ashley, they're coming! They're coming! Oh my god, Julia! We need more time! So sorry for this, Claudia! Ashley! Ashley! I'm so sorry, Claudia. I had to do this. Come on, push in the numbers. Enter.
Access granted.
Welcome to Math Paradise.